We're being asked here if a pair of lines are perpendicular, parallel, or neither. And we need to have theory that will help us out. So the theory here, the relevant theory, is that for perpendicular lines, that the product of the gradients, so m1 times n2, will be -1. That would make them perpendicular. Parallel lines, they're parallel if their two gradients are the same. So that's what we're looking for. And here, neither will be that they're not the same and their product isn't -1. And it's really easy for us to check this out if we put everything into the form of y equals mx plus c, because everything we look at for this has got to do with gradients. So our m is going to be the useful number here. So equation 1 will become, from y plus 3x equals 6, will be y equals -3x plus 6. And therefore, the gradient, let's call it m1, is -3. And we're going to put that in a box and store that away for future use. Let's have a look at our second equation, so equation 2. That says that 6y equals 2x minus 4. And if I want to get it into y equals mx plus c format, I'll have to divide both sides by 6. So y will equal 2 on 6x minus 4 over 6, or a third x minus 2/3. So therefore, my second gradient is a third, m2 equals 1/3. So now let's look at m1 and m2. So I can say now m1 doesn't equal m2. Therefore, they're not parallel. Let's have a look at our second rule. So we know they're not parallel. Now perpendicular, let's have a look. I'll write here to the examiner that they're perpendicular if m1 times m2 is -1. So my left-hand side is m1 -3 times 1/3. Wouldn't you know it? It's -1. So now I'm going to send a final message to the examiner that says, I know that -3 times 1/3 is -1, and that if -1 is the product of the two gradients, it's perpendicular. I can say as m1 times m2 equals -1, these, let's try and spell it correctly, lines are perpendicular. And now I've completely answered the question and I've shown my reasoning. I've even put it in a good red box for the examiner to find easily, and that will send them into joy and raptures. If you found this video helpful, please subscribe or like. Thanks.